Hello class. Today we're looking at section 6.4, simplifying complex fraction. Turn to page 398. Fractions that contain fractions in the numerators and or denominators are called complex fractions. On page 399, you have two methods in simplifying complex fraction. Method 1 says write the numerator and the denominator of the complex fraction as single fractions. Then divide the fractions and simplify. Method 2 says multiply the numerator and denominator of the complex fraction by the least common denominator, the LCD, of the fraction in its numerator and denominator. Then simplify the results if possible. So we're going to look at both of those methods throughout this section. I'm on page 403, and let's look at number 31. 31 says simplify each complex fraction, assume no division by zero. I have x over y minus 1 over x over y plus 1. I see two parts. I see my first part, which is x over y minus 1. I know that the fraction bar means division, divide. And I see my second part, x over y plus 1. How do you divide fractions? Well, when we divide fractions, you have to multiply by the reciprocal. When you divide fractions, you keep, change, flip, or keep it, switch, kiss. So different ways to remember it, but the formal definition is we multiply by the reciprocal. Once I have it all multiplied out, I can start canceling my terms. I can cancel out the x's. I cannot cancel out the y's because they're connected with that minus 1 and that plus 1. Do not cancel out. It has to be the same to cancel out to 1. So my remaining answer is y plus 1 divided by y minus 1. Number 37, same directions. We have 2 over a plus 2 plus 1 divided by 3 over a plus 2. This one looks a little different because on 31, I didn't have a little extra part on the side. This one does. So we want to use that other method. The method that said find the LCD. Let's use that strategy. I still see two parts. I see the first part above my fraction bar, and I see this part here above my fraction bar there. I see two parts. What is my LCD? The only denominators I see is a plus 2. That's my LCD. What you do with that is you take each term and multiply it by your LCD. So I'm going to take this first term and multiply it by a plus 2. I'm going to take just that 1 and multiply by a plus 2. And I'm going to take my bottom part and multiply it by a plus 2. So it's so important that you watch me do this so you can understand what I'm talking about and what I'm pointing at. So make sure you're watching me as I do it. And then you pause and write it down. Now, I multiply each term, or you can say each part, however you want to look at it, by a plus 2. And then I can start canceling out. The goal for finding the LCD and multiplying each term by the LCD is to start condensing that fraction. I want to condense it because I see 1, 2, 3, 4 fractions, like 4 things going on. So I want to condense that. When I start canceling out, things start condensing. Okay? Write down only what you see left over. So whatever I didn't cancel out, write it down. I see, in this section only, I see a 2. I see a plus sign. I see 1 times A is A. I see 1 times 2 is 2. Over. The only thing I see here is 3. Looks good. I condensed the fraction. It looks like a regular fraction. I see a numerator and denominator. So much easier to look at. So now in my numerator, combine your like terms. I have A plus 2 plus 2 is 4 over 3. And that is my answer. Let's try another one. Let's try 39. We have 3 over x plus 4 over x plus 1. And it's divided by 2 over x plus 1 minus 3 over x. Again, I need to find my least common denominator. Everything in your denominator that's different is the least common denominator. I see an x, I see an x plus 1. I see an x plus 1, I see an x. How many different things do you see in those denominators? I see 2 different things. I see x and I see x plus 1. That's my LCD. So for each little section, multiply it by x times x plus 1. And it's going to get a little interesting trying to fill it all in. So I'm going to say x times x plus 1. So make sure you leave some space so you can fill everything in. X times x plus 1. X times x plus 1. And then x times x plus 1. And start canceling out. Right here, I don't need the x anymore. In this section, I don't need x plus 1. In this section here, I don't need x plus 1. And in my last section, I don't need x. Write down everything that's left over. Write down everything that's left over. In the first part, I see 3 times x plus 1. In this part, I only see 4x. In this part here, I see 2x. And in my last part, I see minus 3 times x plus 1. Is that answer in factored form? No. So you do not start crossing things out because it is not in factored form. It is separated by a plus and minus sign. Factor form involves this times that, and so forth. If it does not read like that, you cannot cancel out. If you see a plus or minus sign in between, you cannot cross things out yet. We have to clean this up. And we might be able to cross something out, and we might not. 3 times x is 3x. 3 times 1 is 3. Bring down that 4x. Bring down your 2x. Negative 3 times x is negative 3x. Negative 3 times 1 is negative 3. Equal. Combine your like terms. 3x plus 4x is 7x plus 3. 2 minus 3x is negative x. minus 3. And that is my final answer. I cannot do anything else to this problem. I cannot find a GCF. So we stop there on number 39. Let's go to the next page. Look at number 45. We're still looking at the same directions. 45, you have 2 over x divided by 2 over y minus 4 over x. And I spaced it out a little bit this time. What denominators are different? I have a denominator of x, y, and then x. So how many different denominators did you see? I see 2 different denominators. I see an x and I see a y. My LCD is everything that's different in my denominator. I'm going to multiply each part by xy, xy, xy. And I'm going to cancel out my like parts, okay? So x over x cancels out. Y over y cancels out to 1. And x over x cancel out to 1. Write what is left over. Again, the purpose of multiplying each term by the LCD is to condense that complex fraction. And I want to condense it to where I see only a numerator and a denominator. What's left over? I see 2y divided by 2x minus 4y. And right here, I do see in my denominator a GCF. So let's go ahead and factor out in my denominator a 2. I'm left with x minus 2y. Everything is multiplied together. I don't see a plus or minus in between the parentheses. So because it's in a factored form, I can cancel out again. The 2's do cancel out. So I'm left with y over x minus 2y. That is my final answer. Look at number 55. You have m over m plus 2 minus 2 over m minus 1 over 3 over m plus 2 plus m over m minus 1. Wow, lot going on here. But look at the denominators. You want to see this fraction as like your main fraction, and you want to look at this as if it's the numerator part and this is your denominator part. Okay, but within that numerator I have a denominator. Within that denominator I have another denominator. So we're only looking at the m plus 2, m minus 1, m plus 2, m minus 1. How many different denominators do you see? Again, I see 2. The magic number is not always 2, because I might see 3 different parts, 4 different parts, 5 different parts. So it's not always going to be 2 different parts. But just for these lessons, we only see 2 on these. But it can be more than 2. So I want you to make sure you understand that. Or it might just be 1 part. That's the one thing, one LCD. Just like the previous examples, the very first examples. It was just 1 part that was an LCD. So my LCD is m plus 2 times m minus 1. And then write it again. It can be very tedious, but take your time so you can have that visual. Take your time and write it out. Okay, so now, cancel out. We're going to cancel out m plus 2. M minus 1. M plus 2. M minus 1. And write what is left over. I'm going to do an extra. I'm going to skip a step because we did the step in the previous example. So I'm going to skip a step. So if you don't understand, you need to write it out and look at where I'm at. I'm going to go ahead and do distributive property. Now, if you don't want to skip that step, then you may want to pause it and then you write out the steps and then come back to distributive property with me on your next step. But I'm going to skip that step and go straight to distributive property. M times M is M squared. M times negative 1 is negative M. Very, very careful. I see a minus 2. I must include that negative. So negative 2 times M is negative 2M. Negative 2 times positive 2 is negative 4. If you see subtraction, division, you just have to be careful when you do the math on anything that involves subtraction and division. Okay, do the next one. 3 times M is 3M. 3 times negative 1 is negative 3. Plus sign, so that's easy. So M times M is M squared. And M times 2 is positive 2M. Combine your like terms. I see 4 terms. Don't start doing factor by grouping. Combine your like terms if possible. And then look at your answer. So now I have M squared. Negative 1 minus 2 is negative 3M minus 4 over, I do want to write this in descending order, so I'm going to say M to the second. So I'm going to start off with the highest exponent, which is your degree. Standard form, descending order, we talked about those terms. 3M plus 2M is 5M minus 3. Now, I do see 2 trinomials, so probably going to have to factor. But checking the answer key, I don't have to factor. But if you don't know, you have to do your trial and error method. What 2 numbers can I multiply to get 4 and subtract to get 3? Well, I know 4 times 1 is 4 and 4 minus 1 is 3. And then what will multiply to give me 3 and then subtract to give me 5? Well, I know 3 times 1 is 3, but it doesn't subtract to give me 5. So on this particular problem, I can factor my numerator. My numerator was factorable, but my denominator, it was prime. It makes no sense to factor because you're not canceling out anything. You want to factor again if you can cancel something out. And that's the purpose of factoring rational expressions when it gets to this point. It's so that you can cancel things out to simplify the problem. But because if I factor this and this one doesn't factor, I'm not going to be able to cross anything out. So leave the answer as is. And this will be good enough. Okay, so that's not my section. We have one more to do and then we'll be done. Let's touch on one with a negative exponent. And the directions are still the same. Look at number 61. I have a to the negative 2 power plus a over a plus 1. We still need to remember our property of exponent rules. Okay? We talked about those different property of exponent rules. Let's review right quick. If I multiply, you add the exponents. You divide, you subtract the exponent. A power raised to a power, it equals 1. A power raised to a power, you multiply. A base raised to a 0 exponent equals 1. And when a negative exponent, I have to flip it. That's what we have to do here. So I have 1 over a to the second. And remember that? We talked about that in chapter 5. Plus a over a plus 1. Now, what denominator do you see? If I let this be my main fraction bar This is the top, that's the bottom. My LCD is only a squared. That's all I can multiply everything by. So I'm going to do a squared here. I got to do a squared there. And I got to do a squared here. And when I do my LCD, I am multiplying. So if you don't like the dots, do parentheses. Okay, so you can see that it's multiplication. It's not anything but multiplication. And I tell students all the time that when you don't know, you're probably supposed to multiply it. The a squares cancel here. I'm left with 1 plus a times a squared. Property of exponents rules. When I multiply, I add the exponents. Looking right here, a squared times a is a to the third plus a squared times 1 is a squared. Now, if you missed that and you almost wrote a to the third plus 1, put it in parentheses. That way you know that you're supposed to distribute that a squared. Okay, so right here, I do see something else though. In my numerator and denominator, they're both factorable. So when you think about should I factor, should I not factor, you just have to work it out and see if something cancels out. If something cancels out, you did enough work. If nothing cancels out, you really did too much work. But it's still okay. It's okay. Look at your numerator. This is a sum of 2 cubes. So I have my little parentheses and my big parentheses. And my sign order is plus, minus, plus. It's a little backwards, but you still work it the same way. The cube root of 1 is 1. Cube root of a to the third is a. Square root of 1, square root of a. Multiply 1 and a. In my denominator, I see a GCF, which is a. So I'm left with a squared. My GCF is a squared. I'm left with a plus 1. Tell me what you see. What do you see? I see two things that are the same, but they look different. I see 1 plus a and a plus 1. Do I need to apply the negative switch order that we talked about in the previous section? Do I need to apply that? When I add, does it matter how I add? Let's test this. If a was 2, what's 1 plus 2? It's 3. What's 2 plus 1? It's still 3. So when I add, the order doesn't matter. So these can be canceled out. All you have to do is plug a number in for the missing variable, and see if they equal. And that'll let you know, do I need to do an extra step or can I stop? 1 plus 2 is 3 and 2 plus 1 is still 3. I don't have to do an extra step. They can cancel out each other. And I'm going to rewrite this like the textbook. They wrote this in descending order. So my final answer will be a squared minus a plus 1. So they just wrote it in descending order, 2, 1, 0. Over a squared. And that's my final answer. And again, I want to stress this. We said descending order, but we also use the term standard form. So standard form is when you write that problem in descending order. And that's very important that you know what that term means. Now we are finished with this section. And hopefully you understand it. Please study it because chapter 6 is a little more challenging than the other two chapters we covered so far. So it's so important that you continue to look at your notes and understand everything we did. You have to be comfortable with factoring. So if you don't know how to factor well, or if you still struggle with that factoring, you need to look at some examples, work some problems, watch the videos, or find another YouTube video to watch. And keep practicing on your factoring. And those of you that are taking more advanced math, you're going to see factoring again. So you have to know how to factor. So that's so important. And we also need to know our property of exponent rules too. That's also important. Okay, any concerns? Please let me know.